Okay, so here is the second part of the notes for section 5.3. On number 7, you have cosine squared and sine squared. So I think it's going to be easiest to rewrite this either using your sines or your cosines. So remember, you have the Pythagorean identity, sine squared x plus cosine squared x is going to equal 1. Okay, so I think I will make a substitution for the cosine squared. So this is going to be a 1 minus sine squared x. Oh, no. Yep, that'll equal cosine squared. Just move the sine squared to the other side. Okay, so this is my substitution for cosine squared x. So 1 minus sine squared x equals 3 sine squared x. Okay, I'm going to move. We do have like terms because these are both sine squared. So that cancels. I'm going to have 1 equals, okay, they're like terms. So when I add them, this is going to be a 4 sine squared x. Okay, so divide both sides by 4. And you get sine squared x equals 1/4. So now square root both sides. And you're going to get plus or minus 1/2 equals sine x. So since it's plus and minus, you're going to have 4 angle measures. So sine is opposite. I'm trying to think. It's going to be a 30-degree angle. So in the first quadrant, it's going to be a 30-degree angle. In the second quadrant, it'll be a 30-degree reference angle. So that 30-degree reference angle is going to give you 150 degrees. And then 30-degree reference angle in the third quadrant is going to be 210. And then 30-degree reference angle in the fourth quadrant will be 330 degrees. Okay, so on number 8, this is a quadratic. So you can factor this. So this is going to be cosine or 2 sine x. And I'm going to go minus 1. And then this will be a sine x minus 1. Now, I know I don't have my signs quite correct. Okay, because if I want my last term to be a -1, one of these is going to be positive. The other one is going to be negative. Okay, so that one's going to be the positive. Okay, if I do my FOIL, you'll see that you get a minus 2 sine x there, a plus 1 sine x there. Add those together, and you get that negative sine x in the middle. Okay, now you might not do it that way. Your other option is you can do a box. If you wanted to rewrite this one, so for example, you could rewrite this as like 2 p squared minus a p minus 1 equals 0, and then do a product sum table. And then you can do a box. So this would be a -2 and a positive 1. So in my box, I would have 2p squared, a minus 2p, a 1p, and a -1. So 2p here, 1 here, p, and -1. Okay, so then this is 2p plus 1, and then p minus 1. Okay, then you can just go back and substitute in a 2 or a sine x for that p. Okay, so however you want to do that is fine. On these, there's not very many options when you go to factor it, so I just kind of throw it in, and then I'll mess with it a little bit and find the factors that I like. Okay, so here's going to be 2 sine x plus 1 equals 0. So sine x equals a -1/2. And then sine x minus 1 equals 0. So sine x equals 1. Okay, so on your unit circle, the sine x equals 1, you're looking for a y coordinate. That is 1. That's going to give you a 90-degree angle. And then you want a negative 1/2. So really, it's the same thing we did on the previous one. But if I want negative 1/2, I got to think about what quadrants sine is negative in, which is the third quadrant and the fourth quadrant. So that's going to give you 210 degrees and 330 degrees. So you have 3 solutions to that one. Okay, number 9. This one is another quadratic. Okay, but notice that you've got sine squared mixed in with a cosine. So that is not going to go well. So going back to your Pythagorean identity, I'm going to make a substitution for sine squared, and it's going to be a 1 minus cosine squared x plus 3 cosine x minus 3. So we're going to clean this up a little bit. Let's distribute. So I get 2 minus 2 cosine squared x plus 3 cosine x minus 3. I do have like terms here. So I have a negative 2 cosine squared x plus 3 cosine x, and that'll be a minus 1. Okay, now I have another little issue. My leading coefficient is negative, and I don't like dealing with that negative. So I'm going to factor out a negative 1. So that is just going to change your signs. Okay, now we're doing kind of the same thing we did before. So if you want to make a substitution, kind of like we did if you want to do like a 2p squared minus 3p plus 1. Okay, you could do a product sum table, do that, and then when you get done, you can come back and substitute in a cosine x. Okay, so this one though, you have a positive 1 as your constant. So that means it's either 2 positives or it's 2 negatives. And since your middle term here is a negative 3 cosine x, this is going to be negative. Okay. All right. So now, oops, I forgot a parenthesis. Okay, so now I have 2 cosine x minus 1 equals 0. So cosine x equals 1/2. And then cosine x minus 1 equals 0. Cosine x equals 1. Okay, cosine x is 1, so that means there's an x coordinate that is 1. So that is going to happen only in one place. That's going to be at 0 degrees. And then cosine of x is 1/2. That's going to be a 60-degree angle. Okay, now it's positive, so I do need to find, all snow tastes cold. So I've got the one in the first quadrant. I need one in the fourth quadrant. So 60-degree reference angle is going to be a 300-degree angle. So 60 degrees and 300 degrees. Okay, number 10. Okay, this one is not a quadratic, so we're not factoring, okay? It's just a cosine to the first power. Now, there is this 3x here, and we'll talk about that in a second. So what we're going to do is we're going to move the 1 to the other side, and then I'm also going to divide by 2. So cosine of 3x equals a 1/2. Okay, so we're kind of similar to the one we were looking at, just this previous one. We've got cosine equals a 1/2. So you are looking at that 60-degree angle and that 300-degree angle. Okay, however, it's actually 3x that is equal to 60 degrees and 3x that is equal to 300 degrees. Okay, because if I just said, oh, it's 60 degrees, well, I plug that in. 3 times 60 makes a 180-degree angle. Well, cosine of 180 is not 1/2. Okay, so I know that the cosine of a 60 is 1/2, but if that's equal to 3x, then x must be 20 degrees. Okay, so if I plug in 20 degrees for the x, that will make a 60-degree angle, and the cosine of that is 1/2. Okay, so I know it's a little confusing to think about it. Okay, on this one, x is going to be 100. Okay, 100 degrees. So if x is 100 degrees, then I do 3 times 100 is 300. Cosine of 300 is 1/2. Okay, so 20 and 100 are your solutions for that one. Okay, this is the last one today. So we have tangent mixed in with sine. Here I suggest moving your 3 tangent x to the left. Okay, I think you'll see what's going to work out for us when we do that. Okay, so notice you've got 2 terms. You've got your tangent times sine squared, and then you got your 3 tangent. Okay, think factoring common monomial, you can take out a tangent. So I got tangent x sine squared x minus 3 equals 0. Okay, so now I have tangent x equals 0, and I have sine squared x minus 3 equals 0. Okay, so tangent is 0. I need my y over my x coordinate to be 0. So that's going to be 0 degrees. And does that work for 180 also? I got to think about this. So this ordered pair at 180 is -1, 0. Y over x. Yep. So we got 2 angles for tangent. Okay, now sine squared. So sine squared x is going to be 3. I'm going to square root. So square root, square root. So you have sine x equals plus or minus square root of 3. Okay, now sine being square root of 3, you are not going to find that on your unit circle. Okay, however, you can still find that angle measure. It's just not going to be one of those 30, 60, 90s or 45, 45, 90s. So you can still do inverse sine of square root of 3. Okay, and my calculator can find that angle measure for me. However, when you do that, you get an error message. Okay, so there are no solutions for that statement. If you try negative root 3, it will give you, again, another error message. Okay, so why? Here's your reason why. If you think about the graph last chapter, when you graph sine and cosines, their maximum was 1, their minimum was -1. Okay, so the values for sine and cosine oscillated between +1 and -1. However, square root of 3 is approximately, I think it's like a 1.732. Okay, so it is out of the dimensions for that sine. Okay, sine has to be a value between 1 and -1. Okay, so therefore, that's why you're getting an error message. So there is no solution for that portion of the equation. So you are just having 0 and 180 degrees. So those are your solutions for